All right, let's jump right in. Sepsis is one of the deadliest conditions in any hospital. It's a brutal, fast-moving fight. But what if doctors had a secret weapon in that fight? What if they had a dynamic digital copy of their patient, running simulations in real time to find the absolute best next move? Now, this isn't some far-off sci-fi idea. This is the very real, very ambitious goal of the sepsis digital twin.
So how does it work? Well, the whole vision really boils down to three huge goals. First, you've got to predict, to see where the patient is heading in the next few hours. Then, and this is the really cool part, you simulate. You create a safe virtual playground where a doctor can ask, what if? What if I give this drug? What if I wait 30 minutes? And you can see the outcome with zero risk to the actual patient. And once you can do that, you can finally guide the doctor towards the best possible choice.
Okay, so the promise here is, absolutely incredible. A real game changer. But to really get where we're headed, we've got to take a hard look at where we are right now. And, well, there's a big problem with the current approach. What's super interesting here is that we are not starting from zero. I mean, look at this. There are a ton of these digital twin projects already happening. 60% are patient-based, which, yeah, that totally makes sense. But here's the kicker. Look at what they're all focused on. Almost all of them, the vast majority, are just trying to predict an outcome. They're basically stuck on step one. And that right there is the fundamental limitation. Today's models, they are fantastic at seeing patterns. They can look at all the data and say, hey, watch out, this patient's blood pressure is probably going to drop, which is useful. But it's kind of like your weather app telling you a storm's coming. It's not telling you if you need an umbrella or a full-on raincoat. That's because they're missing causal reasoning. They can't tell you, if you do this, then that will happen. So this huge gap between just predicting something and actually knowing what to do about it, that's what we're calling the causality gap. And believe me, when you're standing at a patient's bedside in the ICU, this is not just some academic idea. It's everything. It all comes down to this one question, the one question every single doctor is asking themselves when their patient is crashing. What should I do next? And that's the one thing that all these amazing predictive AI models, they just can't answer it. Not with any real confidence anyway. And honestly, the issues don't even stop there. The models we have now are, frankly, pretty brittle. You build one for one hospital, you try to use it in another, it just falls apart. They're static, too. They don't update in real time as a patient gets better or worse. They're also what you'd call uncertainty blind, just spitting out a single number without telling you how risky that prediction is. And maybe worst of all, they're total black boxes. They can't explain why they're making a prediction, which you can imagine makes it really hard for a doctor to trust them. So yeah, that's the billion-dollar question, right? How do we build a twin that can actually prescribe an action, not just predict an outcome? Well, the answer, it seems, lies in a totally new way of thinking, a new kind of architecture built from the ground up to finally bridge that causality gap. It's called the hybrid causal model. And this is just a beautiful way to visualize the solution. It's not just one thing. It's this awesome fusion of three big ideas. First, you have mechanistic physiology. This is the ground truth, the actual rules of biology, making sure nothing the twin says is physically impossible. Then you bring in causal inference. That's the why engine, the part that understands cause and effect so you can run those what-if scenarios. And finally, you layer on machine learning. That's what makes it personal, tailoring the whole thing to one specific patient. And right there in the middle, where those three circles overlap, that's the magic. That's where you get a twin that's not just accurate, but also plausible and, most importantly, actionable. And look, this isn't just some pipe dream. This kind of causal approach is already happening. We've got real-world examples in other areas of medicine. Take diabetes, for instance. The Gly twin helps patients figure out the best insulin and diet choices using these exact what-if simulations. Or in heart health, there's a model that can simulate how a heart would react to different treatments, stuff you could never test on a real person. Okay, so the theory is solid, the tech is proven in other fields, but let's get real. What does this actually look like for a doctor in the middle of a chaotic ICU trying to save someone's life?
All right, so first up, the doctor gets this real-time dashboard. And notice, it's not just a single line predicting the future, it's this cone, a cone of uncertainty. Right away, that tells the doctor, okay, here's the most likely path, but it could go anywhere in this shaded area. It immediately communicates the risk and the model's confidence level. Then comes the really cool part, the interactive sandbox. Think of it like a flight simulator for medicine. The doctor can literally ask the twin, okay, what happens if I give more vasopressors right now? The twin runs the simulation and shows them side by side the potential outcome versus just staying the course. They get to test drive their decisions in a totally safe space. And this right here, might be the most important piece of the whole puzzle. When the twin makes a recommendation, it doesn't just bark an order. It explains its reasoning. It says, hey, I think we should increase fluids, and here's why. I predict it will help the kidneys, and there's only a small chance of this side effect. That why is everything. That's how you build trust with a clinician.
Now, getting something this powerful from a concept into a real hospital, that's a huge leap. It has to be done carefully, in stages. So step 1, you build the basic predictive part using old data. Step 2, you add that all-important causal engine for the what-if stuff. And then step 3, the final boss, you take it into a real ICU for a pilot study, running it in the background to make absolutely sure it's safe and that doctors actually find it useful.
And this whole journey, this research, it's all about tackling some really fundamental, really hard questions. Like, what's the perfect mix of biology, causality, and machine learning? How much data do you actually need to make this work in a busy ICU? How on earth do you prove it's trustworthy? And, how do you design it so it actually helps, non-hinders, a doctor and measurably makes patients better? When you step back, what we're talking about here is a massive shift in how we think about AI in medicine. We're moving away from tools that just warn us about a problem to a true partner that can help us figure out what to do. It's an incredible challenge for sure, but the payoff could be enormous. And it leaves you with a pretty wild thought, doesn't it? Could a digital copy of you one day save your life?